First of all, let me say thank you to Gil for organising this event. It's very nice to be back in Australia with the Australian community. And I'm sort of physically in Australia at the moment in Canberra. But it's always a pleasure to be back in Oz, either in person or virtually. And I guess I should thank UNESCO for having a World Logic Day. I mean, it's always struck me as a bit puzzling why there should be a World Logic Day, but hey, I'm not complaining. So let me tell you what I want to talk about. So the talk's called Jaskowski and the Jains, and the guy on the left is Jaskowski. I'll tell you a little bit more about him in a minute. And the guys on the right are Jains. Now, notice that they're wearing masks, but this was taken a long time before COVID. They're extreme pacifists, and they wear masks so they don't sort of breathe in and kill insects. That's what the masks are for. And strangely enough, there's a connection between Jaskowski and the Jains. Of course, there's a difference of about 5,000 kilometers between Poland and India. And the Jain religion goes back to a guy called Mahavira, about the 5th century BCE, rough contemporary of the Buddha. So there's a difference of time of some 2,000 years. So I thought bringing together two things which are 5,000 kilometers and 2,000 years apart would be appropriate for World Logic Day. So that's why I've put these two things together. Okay, so let me tell you a little bit about what they have in common, and then we'll get stuck into details. So many of you will know that Jaskowski is one of the modern founders of paraconsistent logic. So he published a paper in 1948, which is the first real paper in modern paraconsistent logic, where he invented a kind of paraconsistent logic called discursive logic, and you'll see why in a minute. But essentially, information is chunked depending on the participants in a discussion. So information comes in chunks, and to use the tools of modern modal logic to kind of formalize this, and we'll have a look at those in a minute. Now, of course, the Jains knew nothing about contemporary formal logic, but they had a really interesting metaphysics, according to which reality is kind of perspectival. And so the truth about reality also falls into chunks. And so they had this idea of chunking information a long time before Jaskowski. So that's the kind of connection. But what I'm going to show you is that using the tools of essentially Jaskowski's tools, you can make formal sense of the Jain perspective. So it's dressing up Jain thought in modern formal terms. So that's part of the talk. But then what I want to do is bend this back, because applying sort of some Jain thoughts, what you can do is generate a whole new bunch of modern formal logics. And they're kind of many-valued discursive logics. And I'll tell you what those are in a minute. So we're going to go from Poland to India, back to Poland again, and sort of end up roughly in the present. So that's where we're going. So there's an introduction, just had that. I'll tell you a little bit at Jaskowski for those that don't know. We'll talk about Jainism, then we'll talk about Jain discursive logic, and then what I'll call Jain Jaskowski logics. I wasn't sure how much logic I could assume for this audience, but if you're familiar with contemporary modal logic, you're fine. Okay, so that's where we're going. So first of all, Jaskowski. So Jaskowski is thinking of participants in a discourse. That's why it's called discursive logic. And if you collect your information in that way, this is a quote from Jaskowski's 1948 paper. He says it would be proper to proceed each thesis, that is, each thing that one of the participants says, by the reservation in accordance with the opinion of one of the participants in the discourse. Okay, so that's the driving idea. And he relates this explicitly to modal logic. So if a thesis is recorded in a discursive system, its intuitive sense ought to be interpreted so as if it were preceded by the symbol diamond. It's possible that is in the sense of it's possible that A. So of course he was writing before the advent of contemporary possible world semantics. He's doing this sort of axiomatically, but I think it's more illuminating to think of these terms, think of what he's doing in terms of possible world semantics, which is the way we normally think in terms of modal logic nowadays. So what did Jaskowski do? Well, okay. Okay, so let me give you a quick rundown on Jaskowski's discursive logic. So it's pretty much like standard modal logic. So an interpretation is a structure A, W are new, and those are standard. W is a non-empty set of worlds. R is a binary relation on W, and I'm going to assume, as Jaskowski did, that it's universal. So this is S5, but it is a parameter that you can play with, as I'll indicate later. But for the moment, you can think of it as S5. And new maps every world and propositional parameter P to either 1 or 0. So it's a binary semantics. And then those are the truth conditions that you all know and love. I'm not going to read these out. Those of you who are logicians can do it in your sleep. Those who aren't can just sort of have a quick look. Okay, so that's an interpretation. Those are the truth conditions. Then, of course, you need a definition of validity. Oh, I should say that you can define the conditional as the material conditional, and Jaskowski has a different conditional called discussive conditional, which is that thing, because modus ponens for the material conditional doesn't work, so he had to have a slightly different conditional, but that's not going to play much role in what we do, so it's not important. Okay, so definition of validity in standard modal logic, it's done in terms of truth preservation at all worlds, all interpretations. So that's what this thing here says. But Jaskowski went a different way, and this is really what's distinctive about discursive logic. Let's write I don't know how to pronounce that symbol, triangles, the sentence A, just if A is true in some world in interpretation. Okay. So to be true is to be true at some world of interpretation. So what Jaskowski is thinking of is that each participant tells a story, or provides information, and the content of that is what's true at some possible world. That's the key move. And you can then define validity a la Jaskowski, namely A follows from a set of premises sigma, just if in every interpretation, if B holds in the interpretation for every premise, so does the conclusion. So essentially it's truth preservation of truth at some world. Okay, so in other words, in terms of S5, the definition of validity is that where diamond sigma is just the diamond of all the members of sigma, of each member of sigma. And it's not difficult to see why this is a para-consistent logic. A para-consistent logic is one where explosion fails. And of course, you can have A holding in one world, not A holding another, and B holding in none. So explosion is going to fail. So this is how Jaskowski created the first formal modern para-consistent logic. Okay, so that's Jaskowski. Let's move on to the Jains. So as I said, Jainism is a philosophy, it's a religion that goes back 2,500 years now, and they have a really interesting ethics, which is pacifist, but we're going to concentrate today on their metaphysics. And the best way I can do this is just to run through a few words which give you some of the key concepts. They endorse this view called Anekantavada, which means literally non-one-sided way. So for them, reality was a bit like a cut diamond. Okay. So reality has a number of different facets, and different things can hold in different facets. And all of the facets are equally good. So the Hindus might hold that there's a self, the Buddhists might hold that there's no self, and each of those views is equally right in some sense. One view holds in one facet, and one view holds in another facet. And to grasp reality as a whole, you have to grasp every facet simultaneously. It ain't easy, because it's a bit like seeing all 6 sides of a cube simultaneously. I have no idea what that experience is like. You've got to be enlightened to do it. But anyway, that's another story. So Anekantavada is the non-one-sidedness of reality. Okay. There are lots of Naya. A Naya is a perspective or one of the facets of reality. And so, as I said, if you want to understand reality, you've got to understand the contents of each Naya. And so, if you make a categorical assertion describing one of the Naya, it's not exactly false, but it might be a bit misleading. So it's much better to indicate that it's a perspective or a Naya. And for that, the Jains use this word syat, which is a perfectly ordinary Sanskrit word. It means kind of arguably, or it may be the case that, or something like this. But the Jains use it with a sort of technical sense, meaning from a certain perspective. So instead of saying there is a self, it would be more accurate to say syat, there is a self, i.e. from one perspective, there is a self. Okay, now you can already see, in essence, how similar this is to some of the Jaskowski thought, because putting syat in front of something is not a million miles away from putting a diamond in front of it. And that's exactly what's going to happen. Okay. So I'm going to exploit this fact in a minute. But before we do that, I need to talk a little bit more about Jain thought. So Jains have a view called the Saptabhangi, which means roughly 7 categories, 7 predicates. So each sentence can take one of 7 values. Why 7, I hear you cry? Well, because it's 2 to the 3 minus 1. It's easy. Okay, we'll get to that. But let me tell you what these 7 things are. So this is Vadideva Sura, who's a 12th century Jain philosopher. The 7 predicate theory consists in the use of 7 claims about sentences, each preceded by arguably or conditionally, that is syat, all concerning a single object and its particular properties, composed of assertions, denials, and either simultaneously or successively and without contradiction. And they are as follows. Okay, that's a bit dark. Okay, let's look at the details and you'll get clearer about this. So there are 7 categories. Let's look at what they are. So first one, syat, it exists. The first predicate attains to an assertion. 2, syat, it doesn't exist. The second predicate pertains to a denial. Skip over 3 for a moment and have a look at 4. Syat, it's non-assertable. The 4th predicate pertains to simultaneous assertion and denial. Okay, now what you're going to see is that all the other categories are combinations of those 3. Okay, so the first and the second are pretty straightforward, truth and falsity. The third one, that's 4 on this list, is less straightforward. You see, Vadi-Lebesgue glosses it in 2 distinct ways. Simultaneous assertion and denial, well, that makes it sound like both true and false, but non-assertable makes it sound like neither true nor false. So, there's a question of whether you should think of this third value as neither or both. And in fact, Jain theorists argue about this. Some interpret the third category as neither true nor false. Some interpret it as both true and false. I'm not going to take a stand on this. I'm going to leave that for Jain scholars to argue about. We're going to do it both ways so you can see what difference it makes. Okay, so those are the 3 basic categories. Okay, now we'll look at the others. So 3 says arguably it exists, arguably it doesn't exist. So that's a combination of 1 and 2. 5 says arguably it exists and arguably it's non-assertable. That's the combination of 1 and 3. 6 is sciat it doesn't exist, sciat it's non-assertable. That's 2 and 3. And then 7 is sciat it exists, it doesn't, and it's non-assertable. That's 1, 2, and 3. So you can see where the 7 categories come from. It's every non-empty combination of the basic 3. Okay. So those are that's the Jain Saptabangi. Now, let's use the techniques of modern logic to put this into formal drag. And of course, this is completely anachronistic, but I think the Jains would have been cool with that. I'm happy to argue about this methodologically if anyone wants to, but it's not the subject of today's talk. So we've seen that there are 2 possible ways of interpreting the third value, either as both or neither. What I'm going to do to start with is to use a 4-valued logic, and then we'll pull back to the 3-valued case. So what I'm going to give you is modal first-degree entailment. So first-degree entailment is something which will be familiar to most people in the room. It's essentially a 4-valued logic, but I'm going to present it slightly differently. So this is modal first-degree entailment. So an interpretation is a structure, looks the same as usual, W and R as before. This time new maps each world and propositional parameter to a subset of the pair 1, 0. And there are the truth conditions for the connectives that you know and love. They're the classical ones, except that now we're treating truth and falsity even-handedly. So you need independent truth and falsity conditions. In classical logic, if you know the truth conditions, the falsity conditions follows, but that's no longer the case where you have to treat them equally. Okay, so what about the modal connectives? Well, those are those. Again, they're the standard ones of modal logic, except now we are treating truth and falsity even-handedly. Definition of validity. Oh, well, okay, the conditional and the discursive conditional defined as before, but not me really interested in those. Now, in standard modal logic, validity is going to be defined in terms of truth preservation at every world of every interpretation. Okay, so that gives you modal FDE. But what we're going to do is apply the Jaskowski move. So the Jaskowski move is where you define validity in terms of truth preservation at some world. Okay, so again, say that the sentence A holds in the structure A if and only if for some world W, A holds at W. And then you've got the Jaskowski definition, A follows from sigma, just if in every interpretation, if every premise holds in the Jaskowski sense of the interpretation, so does the conclusion. So in other words, same as before, in Jaskowski FDE, an inference is valid if diamond A follows from diamond, the premises, in modal FDE. Okay, so that's modal FDE. And now let's pull back to the 3-valued cases. So if in the interpretation you require that the value of every propositional parameter is I've got this the wrong way around, haven't I? If you insist that nothing takes the value 1 and 0, nothing relates to both 1 and 0, you get K3. And if you insist that nothing gets the empty value, you get LP. Apologies for getting those the wrong way around. And a simple induction shows that in LP, everything is either true or false, and in K3, nothing is both true and false. Okay, so the 2-3 value logics, K3 and LP, are what you get when you restrict the possible interpretations of FDE and cut back to the 3 valued cases. Okay, so a little bit of terminology. Given a formula and a world, there are going to be 4 possibilities, generally speaking. Let's call it a sentence T if it's true, or T at a world if it's true and not false, F if it's false and not true, B if it's both true and false, N if it's neither true nor false. Then in the 3 valued cases, call the third value whatever it is. It's either going to be B or N, Xi. Then given any interpretation, there are 7 possibilities given any A. There they are. Possibility number 1 is T at some worlds, F at some worlds, and Xi at some worlds. And then you just run through the 8 possibilities. There's one of them you ain't got, and that's the last one. T at no worlds, F at no worlds, Xi at no worlds, and that can't be there just because they've got to be some worlds. So the 7 cases of the Saptabangi appear before your eyes. As I said, 7 is 2 to the 3 minus 1. Okay. Now, if I had more time, I'd talk about Tableau. I'm going to skip over that because it's all very routine and boring. Let's just pause for a second at some of the properties of Jaskowski, K3, and LP. So if let's consider the one premise case. If B follows from A in K or modal K3 or LP, then diamond A entails diamond B. So A follows from B in the corresponding Jaskowski version. But the converse does not hold. So in K3 and LP, diamond A entails diamond A, and that's because we're working in S5 at the moment. So diamond A entails A in the corresponding Jain logic. You just knock off the outside diamonds. But of course, that's not the case in the modal logics themselves. So the converse doesn't hold. Let's move to the multiple premise case. So in the modal logics, conjunction introduction holds. However, if you stick diamonds in front, it fails. That's the basis of Jaskowski's paraconsistent logic. So in the Jain version, conjunction introduction also fails. Okay, but in the modal logics, that's K3 and LP, this inference fails. So the inference from A and not A to B fails in the Jain logics. So explosion in an unconjoined form fails in the Jain logics. But if you stick a diamond in front of the conjoined contradiction, that's going to hold in K3 because you've cut out the both case. So the conjoined explosion holds in the Jain K3, but if you stick a diamond in front of the conjoined contradiction, that fails in modal LP because you've got the B case. So conjoined explosion fails in Jain LP. Okay. Well, look, that's just a brief look at some of the properties of these logics. And obviously, if we have more time, we could talk about the general properties, but I want to leave that and move on to the last topic that I want to talk about, which is this. What we've seen is that you can formulate the Jain logic in terms of modern modal logic. And if you treat the third Jain value as neither, you get a sort of K3-ish logic. And if you treat as both, you get an LP-ish logic. Of course, you could, if you want, have both of these things, in which case you'd have a four-valued Jaskowski logic, and there'd be 2 to the 4th minus 1 possibilities. So you'd have a 15 Bangi. I have no idea what that is in Sanskrit. I'll leave that to the Sanskritist to tell me what that is, but you can clearly do it. Okay. So that shows already that you can generalize the Jaskowski construction to produce some interesting things. And since Jaskowski, a number of logicians have indeed generalized the Jaskowski construction by fiddling around with which modal logic you're using and so on. I'm going to ignore that. I want to consider a different possible generalization. And as far as I know, no one has done this before, which is a bit surprising. If any of you know that someone has done something like this, then please tell me, I'd love to know. And what we're going to get is many-valued Jaskowski logic. So all the Jaskowski logics I know are two-valued, but we're going to have many-valued Jaskowski logics. So in the last part of the talk, I'm going to spell out the general construction. But before I do that, let me just remind you or tell you that the 3 and 4 valued Jaskowski logics that we've looked at so far really are many-valued logics. So I haven't set them up as many-valued logics, but it's easy enough to do so. So in FDE, you can think of it as a 4-valued logics, where the logics are these 4 values related to each other in this Hasse diagram, usually called the diamond lattice, where at a world, negation maps T to F and vice versa, and B and N are fixed points. Conjunction is greatest lower bound, and disjunction is least upper bound. The value of box A at a world is the greatest lower bound of the value of A at all accessible worlds. And the value of diamond A is the dual, the least upper bound. So that's modal FDE. And if you, okay, I should tell you what the designated values are, T and B, because they're 2 species of truth, true only and both true and false. And to get the 3 valued versions, you just use the left-hand side of the lattice or the right-hand side of the lattice. So FDE uses the full lattice, LP uses the left-hand side, K3 uses the right-hand side. So I didn't formulate these modal logics as explicitly many-valued, but they are, and you can see how. All right, so I'm now going to generalize and tell you what a many-valued Jaskowski logic is. I'm going to call them Jain Jaskowski logics. Okay, and I'm going to do this in 3 stages. So first of all, let me remind you formally what a many-valued logic is. So a many-valued structure has these components. V is a set of values. D is a set of designated values. C is the connectives of the language. And if C is a connective, FC is the corresponding truth function. And if nu is an evaluation of the propositional parameters, this is extended to all formulas recursively using the appropriate truth function. So I'm writing the connective as prefix here. More normally with binary operators, you'll see it as infix, but you know what I mean. Okay, and then a definition of validity is an inference is valid if every evaluation preserves designated values. So in other words, if every premise is designated, so is the conclusion. Okay, so that's the idiot's guide to many-valued logics. Now, let's move to a many-valued modal logic. And this is all kind of well-known stuff. So given any propositional many-valued structure, okay, I guess there's a U missing there, M, and a complete partial order less than or equal to on V, the values, then an interpretation for the modal extension of the many-valued logic is this guy. Looks familiar. W is a set of worlds, R is the binary relation, possibly subject to constraints you choose, and nu maps every world on every propositional parameter to V. Add a world, the truth functions are evaluated according to the many-valued logic, so each world is kind of many-valued, and then for the modal operators, you do the obvious thing. It's exactly the generalization of modal FDE, modal LP, modal K3. So the ordering must be complete, otherwise there's no guarantee that the greatest lower bound and the least upper bound exist. But if the order is complete, then of course they do. And therefore, we need one last thing, which is the definition of validity, and that's obvious, namely an inference is valid if in every interpretation the inference preserves designated values at all worlds. Okay. So I told you I was going to do this in 3 phases. The first is many-valued logic. The second is modal many-valued logic. We haven't quite got to Jain Jaskowski logics yet. That's the next step. But I mean, everything I've said here about many-valued logics, modal many-valued logics, is completely standard. I mean, you can find it, for example, in my introduction to non-classical logic. So the only new move is what is coming next. So we're now going to make the Jaskowski move. So here we go. Given a modal many-valued logic, its corresponding Jain Jaskowski logic is exactly the same, except that we make the Jaskowski move. So a structured triangles A, if A is true in some world, okay, and then validity is defined as truth preservation, or rather designation preservation at some world of every, okay, there's a quantifier issue here. Let me just read it. An inference is valid if in every interpretation, if B holds in A, that is it's designated, at a world, then so is the conclusion. Okay. In other words, it's the familiar formula that Diamond A has got to follow from Diamond premises in the modal many-valued logic. Okay. So, as far as I know, that is a whole new bunch of Jaskowski logics, that is non-adjunctive paraconsistent logics. And I'm kind of surprised that no one's thought of this before. But if anyone knows about this construction elsewhere, then please do tell me. So, but I mean, generally speaking, what this talk does is illustrate the interplay between contemporary thought and ancient thought, which is, I think, often fascinating, and new insights can emerge in both directions. So we've seen that in today's talk. So applying the techniques of modern modal logic, you can give a very precise sense to the Jain metaphysical picture. So that's something that makes Jain thought interesting, even more interesting from a contemporary perspective. But then we've also seen that looking at what Jains do with their perspectivalism, it generates a whole new bunch of modalish logics, non-adjunctive paraconsistent logics. So that's kind of interesting too. So thank you for your thoughts. Yeah, I've held this down to 45 minutes. So thank you. So arguably this is the end. Oh, so you can see what this picture is. The thing on the left is a sort of a Kripke model. The thing on the right is Jain symbolism. Let me just say something else about this before I finish. I gave a version of this talk in Poland earlier this year, and I showed this picture at the end of this talk, and there was a gasp from the audience because it's illegal in Poland to show a swastika in public. So the audience was just horrified that I'd shown this slide. Okay, now, some of you will know that the swastika is an ancient Aryan symbol, which is a sign of holiness. And it's a Jain symbol for holiness. But if you go to India or Japan or places in China, you will see a swastika on every temple you walk past. And I must confess, the first time I went to these countries and walked past these temples, I had to do a double take. But that's why the Jains use the swastika as a symbol of the holiness of their view. The Poles didn't know anything about this, of course, and I was sort of scared I was going to get arrested before I left Poland. Anyway, thank you.